is going to be how do you make these? So creating these things is not super easy. You can use hash functions to create these. That's one process. So we've got some hash functions out there, and we can use hash functions to create message authentication codes in a variety of ways. So the difference again between a hash function and a message authentication code is the addition of the secret key. That's the new thing that's coming in here. So for each of these methods, we have to pick a secret key. And then we're going to assume that we're starting with a hash value H. Okay, so we're adding the secret key, and then we have to kind of revamp our hash function a little bit to incorporate the secret key. There's something called the secret prefix method. So the way that we are going to do our message authentication code is by appending the key to the beginning of the message. Those two vertical lines mean concatenate or squish together. So we're just going to squish the key at the beginning of the message, and then we're going to hash it. Whether or not this is secure, not totally sure, but that's the secret prefix method. Similarly, we've got the secret suffix method. So if I were in class, this would be the dumbest question of the day, and I'm not going to ask you because nobody's here to reply on Zoom. But if the secret prefix method puts the key at the beginning, the secret suffix method puts the key at the end. So you just squish the key onto the end of the message, and then you create the hash value that way. So we've got secret prefix or secret suffix method. And then we've got the one that sounds way more interesting. Envelope method with padding. It sounds pretty cool. It's not, but it sounds pretty cool. So what we're going to do with this one is come up with some padding P to make the key long enough. And then we are going to take the key and padding and the message and the key again. So the envelope is the key is at the beginning and at the end both. We're kind of putting the message in a key envelope, basically. And the padding is just to make sure that we don't have just the key hashed at the beginning. We want to make sure that the key is at least one block long. So that is the envelope method with padding. It sounds way cooler than it is. It's not that cool, but it sounds way cooler than it is. So this is one way to create message authentication codes. Take an existing hash function and wrap a key in somehow. John, yes?
Could you just explain one more time why there's padding
Why
for
there's
the key at
padding?
the
Yep.
front versus and not at the end?
Could be either place, but I want to make sure that I'm not hashing, if I break up my message into blocks, that I'm not hashing just the key at the beginning. I want to make sure that I'm hashing the key plus some other stuff. Because if you just hash the key, I want to make sure the key is over multiple blocks, because if the key is all in the first block, then I have potential issues. So we want to make sure that it's over multiple blocks. You could put the padding anywhere you wanted, really. It could be in the middle, it could be at the end. We just want to make sure that the key and padding is longer than a single block. Again, it's not that exciting.
Yeah, I'm just wondering why it's alone at the end, because
Could be. It could. We're assuming that the message is going to spill over into the last key, so the
okay.
message kind of provides some inherent padding. Does that make sense?
Yeah.
Okay. Other questions? Other ones on these? Okay, so then the other way to create message authentication codes is to start with a totally different function. Not start with a hash function at all and tweak it a little bit, but start with a totally different function. That's your other process for creating message authentication codes. And now we are getting into my research from grad school, which is what I will be talking about on Monday. So Monday, come back, please. It's fun. There's a little bit of abstract algebra for people who have taken abstract algebra. If you haven't taken abstract algebra, that's fine. I will talk about the necessary stuff that you need. But Monday is going to be an example of a practical, well, sort of, because I'm a theoretical cryptographer, but as practical as you can get, practical message authentication code. So we'll see an example. And I promise you that the protocol for this is way less complicated than the protocol for SHA-1. I promise. It is nowhere near as complicated. All right, so that is Monday. Come back on Monday and we will talk about my research from grad school that took me, well, probably 4 years to do, and we'll cover it in a 50-minute class period. It'll be great. Anything else for other questions? I will update the presentation schedule on Moodle and fix Sarah and Joshua. Sorry about that. Other questions, either on presentations, message authentication codes, anything. Elijah, yes.
For hash functions, I actually looked ahead at the homework. How do you want us to show whether or not a hash function has pre-image resistance? And what was the other one?
Weakly or strongly collision free?
Yeah, collision. Yeah.
Yep.
How do you want us to show that? Or like optimally we would prove it. But
yeah, no, proving it is going to be hard, very hard. So I am looking for kind of a verbal explanation.
okay.
Does this seem like it has collision resistance? Does it seem like it is, or collision free?
So-
Does it seem like it has pre-image resistance?
Okay. For the collision resistance, would maybe like an empirical study work?
Yeah, you could try that.
The
Yep.
values, that sort of thing.
Yeah, we're not looking to be super mathematical at this point. We're looking
Okay.
to kind of do some analysis and be more verbal than, and this is where it's interesting too. Cryptography kind of diverges into mathematical cryptography where they would actually give like an actual proof for these versus practical cryptography where we just say, yeah, probably this has these properties. So I'm asking you to go more on the practical side. Daniel.
Yeah, I was just gonna say, so, but if it's like easy enough, could we just like, because it's easier to prove like that it's not collision free, right? If you can come up with a counter example.
Yeah, so if you can find a collision, that would definitely demonstrate that this is not collision free. Yes, that would be a way to do it as well. Yep.
Thanks.
Okay, anybody else? Other questions at this point in time? Good. All right, I will get my slides up for Monday. They're gonna look a little bit different because it's from a presentation that I gave and they're not PowerPoint slides. So I will get those up, and then Monday is fun because I like talking about my research at least a little bit. So have a lovely weekend. Let me know if you have questions about presentations or anything else with logistical issues, and I will see you guys on Monday. Thanks, bye guys.